Yes, to the Professor Dr.Dolphy Gilpin here, and we're on some NASA. We're returning back to some NASA notes here. And what we have for NASA, we have the Executive Order EO and a couple of abbreviations here. I've already read nearly 10 pages of this 67-page abstract with introduction, executive order, and I've extracted some of the mnemonics that would be quite relevant in understanding what is being written. What is on nuclear, the use of nuclear elements and nuclear power and energy to energize projects for NASA for future up until 240. And so what it is called now the SNS, or the Space Nuclear System, EO Executive Order 13972. And it's available, and it's also available to the public, so there will be no copyright infringement here in doing that. The EO Executive Order 13972, Space Nuclear System, and with it you will have certain mnemonics that would be relevant to understanding what we're talking about. We're talking about HEU, which will be highly enriched uranium, which is proposed to be used, and LEU, low enrichment uranium. So we have low enrichment uranium and high enrichment uranium. Well, I guess if you want to economize, then the low one would be economy. But I guess for quality, the high HEU would be there. But I choose safety. So whichever, the low or the high, whichever one would be safer, then that's the one is to be used. But then there's a trade-off. If you use high and low, and one of them probably will generate more heat. And so you have something called the NTP, which is the nuclear thermal propulsion. And if you generate a lot of heat, you have to know to cool it down. So you have NTP, nuclear thermal propulsion. You also have the RPS Radiostppe Powersyntem. These are abbreviations that will be necessary in understanding the abstract. The SNAP SNAP System for Nuclear Auxiliary Power. You have the NEP, which is the Nuclear Electric Propulsion. You have the RTG, the Radiostope Thermal Electric Generator. And in the WBS, which is the work breakdown system, number 039889, like I said, I've read up on the abstract and acquaint myself with it. So the WBS work break structure, and HEU, highly enriched uranium, and LEU, lowly enriched uranium, and the NTP, nuclear thermal propulsion, and the DARPA, and the NERVA, nuclear engine for rocket vehicle application. and STMD, Space Technology Mission Directive. So those abbreviations will come in quite tangible for you to understand the abstract of this EO SNS NASA SNS EO 13972 abstract for promoting small nuclear reactor for space exploration. So I urge those who want to continue this thing and to read upon this, show how we could use these nuclear energy, nuclear elements, uranium, plutonium, cesium, strontium, all of those are some of those transition elements to energize the vehicle going to Mars, or future vehicle Titan, the one going to Titan there, and to Pluto, the Dragonfly, and so on. All of those vehicles, there's a proposal to energize them via nuclear energy in the future. And those abstract, some of them are very long abstract, will guide you into the understanding and into the planning and direction it will take. So that's it for the nuclear application, nuclear elements application for future NASA project. And you have heat, power, and propulsion missions for application for NASA.